Hi, my name is David Zaski.
And I'm Katrina Hansen, and today we are exploring current graphs for resistors and diodes. Our setup for the circuit is we have a power supply, which is our DAC, and our DAC voltage is between -5 to +5 volts, and then we wire that to our shunt resistor, which is 1k ohms. And then, because this is a known voltage, we can measure our voltage across the resistor and get the current for our circuit across the first resistor. And this is V1 in our LabVIEW program. And then we have another resistor, and this is going to be a resistor, an LED, and a diode. And we're also measuring the resistance against this, which is showing up in LabVIEW as V2. And finally, goes back to ground.
Our green wire is connected to A01 on our DAC, and it is the output of the voltage to the breadboard. The yellow wire is connected to AO ground. The red wire is connected to AI0. The black wire is then connected to AI8. The pair together measures voltage over our shunt resistor. Our DAC can't measure current directly, so by placing our wires this way, we were able to measure our voltage over our 1 kilo ohm resistor, and using Ohm's law, we can solve for our current. The blue wire is AI2. Our white wire is AI10. This measures our voltage of our device under test.
This is our first setup, which utilizes a 100 ohm resistor, and we are using a resistor of known resistance so that we can ensure that our LabVIEW VI is functioning correctly.
The first DAC assistant controls the voltage into the circuit, which we set to a range of plus or minus 5 volts. The second DAC assistant measures the voltage across the shunt to determine the current of the circuit, which is measured in milliamps. A waveform chart on the front panel displays the values of the voltage that the DAC is inputting to the VI. The third DAC assistant measures the voltage from the circuit across our device under test. The data is graphed in a current versus voltage graph. The slope and intercept are calculated, and the resistance is determined by taking the inverse of the graph's slope. The VI has now returned a resistance value of 0.1 kilo ohms, which is 100 ohms.
Here, our device under test is an LED, which we have connected in series with our shunt resistor. We ran the LabVIEW VI, which, as we see here, returned a resistance of 2.29K.
This run, our device under test was the diode, which we have connected in series to our shunt resistor. This time, it returned a resistance of 4.35 kilo ohms when we ran the LabVIEW VI.
We used our VI to determine the voltage across our shunt resistor, and this allowed us to calculate the current in our circuit. We were then able to use this information to calculate the resistance of our devices under test.